This is activity 3, lesson 6 on similarity, activity 3, similarity transformations. And this is part 2. This is more practice on translating, actually transforming the sequence of transformations, either translating, reflecting, or rotating, and also sometimes combined with a dilation to move this image around. Now we're starting with this image and we're going to move it through transformations and dilations. So the image we end up with has to be similar because we're starting with this image and we're just moving it around. We're going to end up with a similar image. If you wanted to prove it, then you would just reverse the process if you were given these two images. I'll talk more about that as we get through this. So the first one says, take this image and do a translation and a reflection on this image. So a translation, that means just move every point in a parallel direction. They all have to move the same distance and in parallel to each other. Now you could move them vertically, horizontally. I just moved them at a diagonal here. So you can do it any way you want. You just move it through the plane, but all the points have to move in the same way. Points move in parallel. Okay, and then next is a line of reflection or reflection. So you have to draw the line of reflection wherever you want to reflect it over. So draw that line, and then each of these points are going to move in a perpendicular direction to that line and then end up on an equal distance on the other side of that line for the reflected image. So you move each point an equal distance on the other side after moving it perpendicular to the line. So that means at a right angle once again. So this is the translated image, this is the reflected image, and if you wanted to prove that this was similar to this image, you would just reverse the steps. You could go back, you could reflect this back, and then you could translate this back. Or you could do this translation first and put this point right down here, and this could be the line of reflection. You reflect it back over. Okay, line of reflection, this is the second one. I'm going to take the same image, a reflection and a dilation with a scale factor greater than 1. That means you're going to make it larger. So you can choose anything you want as long as it's a scale factor greater than 1 and it makes it larger. So I thought it'd be a little bit tricky here. I chose a line of reflection that's right down the center here. Now I found the midpoint by using docere. If you just take a line in docere and put it close to this line, it will snap to the midpoint. So I knew that was the midpoint, and then I drew a line straight up. So this is a line of reflection. And remember, when you reflect something, you take each point, you move it in a perpendicular direction to the line of reflection, and then an equal distance on the other side. That's a little bit tricky because a couple of the points are going to the right, a couple of points are going to the left. So it's just going to flip over. The short side is going to be over here, and the long side is going to be over here. So you move it on an equal distance to the other side, place those points, and connect them. Place the points and connect them. Now it gets a little bit confusing. You got to be careful. You have to connect these points. It's easier if you label, and we're going to see that in the next couple of activities, of the parts of this activity. So you connect those points, and you get this. So it's been reflected. This long side now is over here, and the short side that was here is back over here. And then the next step says dilate it with a scale factor greater than 1. So I chose a scale factor of 2, and the center of dilation is right here. So you can choose the center of dilation anywhere you want. I chose it to be right here. So that means I'm going to draw a line from this center of dilation through each of the vertices, and then I'm going to go twice as far on the other side. So I'm going to draw a line from here to here, from here to here, from here to right here, and here to here. So twice as far on the other side. Draw the line, double it, or it's a scale factor of 2, so double it twice as far on the other side. So double this length. So I'm drawing lines from the center of dilation to each vertex. And that becomes the unit length for that part of the dilation. So that's 1 unit, and twice that is going to be 2 units. And then finally this one here, and double it, and then connect those points around. You end up with that image. Get rid of everything. And I'm just showing you the arrows going through each of the vertices. Now this one was a little bit weird because this one was almost right on top of this one. A little bit displaced there. All right, the last one. No, this is not the last one. This is the third one. So center of rotation, I chose the center of rotation to be right here. It says a rotation and a reflection. Doesn't give you any idea of what this, actually, okay, a rotation and a reflection. So I chose the center of rotation right here. And I chose to draw all of these circles through each vertex. So I'm going to rotate this around. I'm going to show you an easier way to do it in just a moment. But this is kind of a fun way. And you can do this in Docere once again. So you draw these circles. They all have the same center. And then each angle, each vertex, as it rotates around, has to stay on its path. So each of these angles, each of these vertices have to remain on its own path as it goes around. You're going to go around 180 degrees, and it's going to end up right here. So when these line up, you've gone around 180 degrees. Now remember, when you have a 180 degree rotation, you can connect each of the corresponding points, and they are equal distance from the center of rotation on each side. So if I connected these two corresponding points, they're an equal distance on each side. If I connected this point with this corresponding point right here, it's an equal distance on each side. Same with this point way down to here. So I'm going to use that fact to do this much easier, in a much easier way in just a moment. So center of rotation, 180 degree rotation. So if this is the center of rotation, I can connect each corresponding point, draw a line through the center of rotation. It's because it's a 180 degree rotation that it works this way. I'm going to draw a line through the center of rotation and an equal distance on the other side. Draw a line through the center of rotation and an equal distance on the other side. And I'm going to label these each time to make it a lot easier to figure out how to connect the points and in what order to connect the points. So I draw a line through the center of rotation from this vertex, an equal distance on the other side. Through this vertex, an equal distance on the other side. And then it goes just the opposite way, through this vertex and an equal distance on the other side. So label each point as you draw them, so you know this is D and this is D prime. This is E and this is E prime. So you know what order to connect the points in. Otherwise, I didn't do that at first. I got very confused. So A prime to B prime to C prime to D prime to E prime, and E prime back to A prime. So that's the rotation, and then you're going to do a reflection of this. So get rid of all that. So that's the rotation. And this is just showing you that I'm connecting them in order. So it makes it easier if you label the points and connect them in order. Okay, now a reflection. Yeah, reflection of this. Line of reflection, I'm going to use this line of reflection right here, this side. So B prime, C prime as the line of reflection. So draw the line of reflection. Remember, a reflection is you move perpendicular to the line of reflection and an equal distance on the other side. So you place these points at an equal distance, and then I would label them. This is A, you could label this A double prime. This is B double prime. This is E double prime to here. This would be D double prime. Actually, let me see what I did. I even got confused now. So A double prime, E double prime, and D double prime. And C and B are on the line of reflection, so they don't get moved at all. All right, so A double prime to, this should also be B double prime, to C double prime, to D double prime, to E double prime, and back to A double prime. Get rid of everything. So this is a 180 degree rotation and then reflection over this line of reflection. So this image, this figure has to be similar to this figure. Actually, it's congruent because we did no dilations. We just did transformations. And the last one is a dilation with a scale factor less than 1 and a translation. So I'm going to make that scale factor 1/2. And I'm going to put the center of dilation right there. You can put it anywhere you want. So I'm going to draw a line from the center of dilation through the vertex, and then you bring each of these points in halfway of half of that distance. So here's lines to each of the vertices, and then you place a point halfway, and that's where your dilated image is going to end up, the vertices of your dilated image. So then you just connect these points around. Remember, they run parallel to the original image. So connect all these points. And so this image is scaled using a scale factor of 1/2. It's scaled 1/2 the size along each length as the original image. And then translate that. And so the only point about a translation is to make sure you move every point the same distance and parallel to each other. Those two things, an equal distance, and they all have to be parallel. Again, you can move it straight up, you can move it straight over horizontally, but I chose to move it at this angle, an equal distance for each point, and parallel. All right, so this was the first one, a translation and a reflection. The second one, a reflection and then a dilation. The third one, which was a rotation around and then a reflection. And the last one that we just did, which was a dilation of 1/2 and a translation.